Hi friends, welcome back to another video of unsupervised learning. So in the last video we have seen the type of clustering. So today we are here with another type, that was hierarchical clustering, right? So we will see this analysis on the basis of some customer data. Let's see how the hierarchical clustering works. So let's start importing all the necessary libraries: pandas, numpy, matplotlib, right, and G score from statistics purpose, then as seaborn for printing our graphs. Now reading the CSV file into pandas data frame. So again, this is the customer data and we are reading customer span data.csv. I'll be providing the link in the description as well, so you can find it from there and import it in your notebook as well. Now getting the head of this data frame, right? So it will return top 10 rows. So here you can see we have customer ID, name, average monthly spend, number of visits, appraisal items, right, function v item and stable items. So here what we are doing is we are taking that customer data attribute, right? Just take customer.ilog, right? It will take all the rows but the column from second to rest. So here you can see that 0 1 2, the second column is our average month spent and all the columns from this one, right? So it will contain all these, because before that you can see we have the customer ID, index and name, which is not the further useful in this case. Now customer data is scaled, we will apply Z score here. So customer data attribute dot apply, we are applying Z score, and customer data scale, we are getting the top 10 head again. So you can see that after applying the Z score, right, how the value got distributed in these values. So let's import our seaborn for statistical plotting. So here we are doing the pair plot of customer data scaled, height equals to 2, aspect equals to 2, right, diagonal kind equals to our KDE. So here you can see that we have the pair plot now. Now from sklearn.cluster import agglomerative clusterings, right? So if we import this agglomerative clustering, so model equals to agglomerative clustering and cluster equals to 3, affinity equals to Euclidean, linkage equals to average, right? Now model dot fit customer data is scaled, so agglomerative clustering, we are again calling the function and getting this agglomerative clustering here. So this is nothing but our hierarchical clustering, right? Now customer data attribute labels, we are taking model labels, okay, and customer data attribute dot head, we are again getting the head of all the data, right? Now cluster data cluster, we are grouping this by labels, okay, and getting the mean now. So here you can see we have label for 0 1 2, we have grouped it for all the attributes. Now we are importing coffeenet dendrograms and linkage, right, that we will be using here. And we are also importing pdist. So this is nothing but pairwise distribution between data points, right? So here the first one is coefficient. Index is a measure of the correlation between the distance of a point in feature space and distance on dendrograms, right, which is closer it is to 1 and the better is it the clustering. Now Z equals to linkage, we are taking a customer data scaled, matrix equals to Euclidean and method equals to average. And C dot coefficient distance, we are getting coefficient, right, from here. Z pdist of customer data scaled, and finally printing the C. So here you can see in this case we are getting the C as 86%. Now if we plot the same thing here, agglomerative hierarchical clustering dendrograms, simple index for our X labels and distance for our Y labels, and dendrogram we are passing this G, right, leaf rotation that is 90%, color threshold is 40, leaf font size is 8. Now plt dot tight layout. So here you can see the hierarchy that we got here. So 0 2 3 7 8 5 6 1 4 6, and all these are interconnected, and finally they make a hierarchical here. So which where the 86 is nothing but a good score, right? Below we have the same thing repeated. So would like to wrap up the video here. Hope you got the slight idea that how hierarchical clustering worked. We will also use further implementation of the clustering like in project or in our case studies, right? So stay tuned. All the best. Thanks.